We're going to test PETN at a value of 25 millijoules. So I'll shoot some backgrounds with silica sand. Test substance PETN. 25 millijoules. And I'll do 5,6. Let's do 8. 5,6 is the first 4, and then 8 the next 4, and then 11 to 16. So we'll do 8. Here's my reference, sand. Collect baseline. Camera should be at 8. Left stop. Now. Camera is triggering. There is our baseline shots, 1 through 25. Camera triggered properly. I believe the advanced setting is as far as the trigger. It's on falling edge. We can just check that. When I shot that, it was on. I go to advanced settings, down to the trigger. It was on rising edge with a filter time of 0. So it can be on falling edge as well and work, and with a filter time of 5 to 10. This particular time we used rising edge, 0 time. And this is what we got. So yeah, the box plot looks good. There's a couple of outliers. There's one that's 6.23, close to that cutoff of 6.25. And one that's 6.35. Okay, now we'll collect some shots with PETN. There's our PETN sample. Hope you can see that. We collect the trial. And no go. Do about 10 shots here. Nice. 10. So we'll process those last 10 we just shot. 25 millijoules with an 8. Number 8. There was 10 no-goes there at 25 millijoules. So we'll go up in energy. This is shot at a number 8 aperture opening. We'll go up a few to 0.02 by a factor of 10. See what we get, how many goes we get. shoot baselines. Our camera's all set up already. We use sand as our baseline. Again, you don't have to reapply the sand between each baseline shot. Change settings. PETN, this time we're going to go up to 0.02, which is 260 millijoules. We'll do 11. Aperture. Collect baseline. Load a PETN sample. While that's processing. And our box plot looks good. There's no outliers. That looks really good. Collect trial. It was right on the edge there. Try again. We'll just process those last 5. We can look at them. It's 5 no-goes according to the software. go up in energy. Put some sand on there. Change settings. We'll go up to 0.1 microfarads, which is 1500 millijoules. We'll do 11. Aperture size of 11. Collect baseline. Let's see. Go. That's a good one. Two goes out of 2 trials. We'll do a few more. It's 3 for 3. 4 for 4. And 5 for 5. So you got 0, 0 out of 10, 25 millijoules, 0 out of 5 at 260 millijoules. We just got 5 out of 5 at 1500 millijoules. So we'll stop GoDetect, and all of the files are under GoDetect data under the C drive. So C, GoDetect data, ESD. The baseline runs are under baseline, under silica sand. You can see all those. If you were to click in here like the last one we did, there's a baseline summary under 1500 millijoules. You can open it with Notepad. It will show you the file name, where it's located, the brightness, buoyancy, shape, uniformity, and color values. So you can see how they vary and their values. I should have pointed out here, let me open it up again. Here at the top, no, it's not in that one, it's the other one. So when you go to the actual data here, we were in PETN, 1500 millijoules. Here's the 5 shots we ran. You can also see in 260 millijoules, there's the 5 shots we ran. You can see here, this is the brightness, buoyancy, shape, uniformity, color from the background, and it lists which background it used to get those baseline shots, their mean and standard deviation. And then here are the brightness, buoyancy, shape, uniformity, and color values, and then the linear combination of those to yield that trial value. And it compares each one of these individually to the baseline values to arrive at that trial value, and then lists no-go, and then summarizes 0 out of 5 there. You'll notice it's not listed here under 1500 because we didn't do the process the multiple files. So if I open that up again in GoDetect, hit ESD, pick where I was, that's the last place I was at. I can analyze trials and hit multiple files, and now it will create that summary file. It doesn't do it automatically. You have to do the looks like I hit it twice, but you have to hit multiple files for it to generate that summary, and there's that summary it just made. And there's the brightness and buoyancy, shape, uniformity values, and the trial values. You can see in this case, I think you can see it here. You can see here that the brightness values are around 400. Those are similar to what was shown here. The buoyancy was 330. So buoyancy here, negative, means the light is traveling upwards, and you can see it's significantly different than 330 because it's opposite sign there, so that's significantly different. And then shape, this is 487, where we're up at 1500, that's different. Here's the uniformity value, we're close to that, and the color value, we're different in color as well. So that's what it uses to get this trial value.